Hi, I'm Thomas Overbey, and I want to welcome you to Ultra Clean Connect. We've had the privilege of doing several sessions, and with regards to talking about our machines and the bottlenecks that you can encounter in sterile processing department, and we try to alleviate some of those pain points for you. We're going to have a couple of more sessions for you later in the week. We'll feature our Triton series machines on Wednesday, and also on Thursday, we're going to review all of our machines. We also have gifts and things we've been giving away in the previous sessions that we've had, so stay with us. At the end, we're going to give you a code to get a CE course credit that we're going to provide for you today. And then also we'll have a list of the things and the means with which you can register to be selected or entered in to win a few things. Okay, so our topic today is on cavitation. And I want to mention to you that Gettinga is the folks that I want to give credit to, a shout out, because they gave us this opportunity today, this time slot, to talk with you. So I do want to mention that they are our exclusive distributor for all of our products. So with that, I wanted to move forward and say this. Did you know that cavitation can equal the temperatures of the sun or even exceed it? Now, how does that happen without burning a hole to China in your equipment? Well, for a very infinitesimally small amount of time, that temperature does reach extremely high temperature, but it's such a short moment in time that we don't render any damage to our equipment. So I think I find that interesting, and I think you do too. But so let's go down this road a little bit about cavitation. But first, I want to thank you. And from the bottom of my heart, I want to thank you that all the things that you do every day tirelessly to keep patient safety high. And I really mean that. I would like to also extend to you that if we if we never strive for improvement, we would never advance. We're continuously advancing with continuing education and being good motivators and stewards in all of our work. It's always a process. We're in a process of processes. So let's talk about cavitation. With UltraClean, we clean instruments. We clean surgical instruments. That's what it's all about. So thank you for coming in, and we're going to talk about cavitation and why do I care? Why do you care? Let's break it down a little bit. Okay, so sonication, sonic is sound. In this example, we have a bass guitar. You see the strings vibrating on the left side of your image, and then a speaker outputting that waveform, that bass note. And it's a few vibrations per second. It's low sound. Now, each one of those vibrations, the speaker is moving in and out. When it moves out, it's pushing the air to your ear. That's a positive vibration. That's the top of that waveform. And then as it gets to the bottom to complete that one cycle, okay, then that's a negative air pressure moment. And we'll talk about that negative air pressure in a moment, how that relates to cavitation. But if you increase the frequency a little bit, say that with a flute, and its corresponding waveform, it's much faster. The vibrations are more of them per unit of time. But now when you take this and you put all this energy that a machine does for you underwater, bubbles begin to form and a whole different thing begins to occur. So let's talk about these gaseous bursts that are happening underwater. Let's talk about the cavitation machine itself, your ultrasonic machine. Now, we've seen instruments, right? A bass guitar and a flute. Here's the generator. That is your musical instrument for your machine. And then you can see the waveform is very high. It's ultrasonic, out of the range of hearing. Of course, you can hear it hissing, but you can't really actually hear or perceive the actual pitch. It's out of the range of hearing. But what's happening? Where does the energy come from, or how is it produced and emanated in, how is it that it emanates in the basin? And we have our speakers. You have rod transducers and bonded transducers. Just like in your phone, your car stereo, your television, it has speakers in them. Those are transducers. And these are what produces the sound. So let's talk a little bit now how the sound producing things in your in your basin actually produce cavitation, and we'll discuss that through the process. Okay, so if you look up in A, these negative air pressure moments that I mentioned a moment ago, when these cycles of sound are at the bottom of their cycle, you have these low pressure events that occur, and a bubble is formed. A gaseous bubble occurs in the solution that otherwise a bubble shouldn't or couldn't exist. And so in B, you have a jet that's being formed and a bubble beginning to invert in itself, because again, this gaseous bubble is in this space where it shouldn't be, and it needs to actually implode in on itself so all the water can go back to where it was without the occupation of the bubbles in that space. In C, you can see an extenuation of the jet. It's now beyond the bubble itself. And in D, it has no choice but to completely implode on itself. But this is where this very massive little disturbance created in water. But it's these little disturbances that are massive times, millions of times in small amounts of time, create this great cleaning power called cavitation. So here's an nice little animation that wraps it up for you very clearly. The jet's being formed from the negative environment or the negative space. And this happens over and over again, ultimately helping all these little implosions, these little explosions, these disturbances, if you will, to render your instruments clean. I think that's something you all can really appreciate. There was the other transducer I showed you a moment ago, and that's the bonded transducer. We'll talk about both types a little bit, but this one is interesting because it emanates your energy radially from the transducer itself. And what that means is you have a differing way of looking at things. Let's break down this energy, this cavitation energy, particularly this case from the bonded transducer. I'm sorry, the titanium rod transducer, the rod form of your speaker. In terms of high frequency, smaller bubbles can affect cleaning in smaller areas, but take considerably longer to clean. Okay, so higher frequency, higher than we're still talking about ultrasonic, but much higher than, say, lower. And these bubbles can get into spaces much more finite in size, but they're small, so their impact is less than if there was lower frequency where larger bubbles are formed. Larger bubbles have much greater cleaning power in less time. Smaller bubbles take considerably longer to clean, and time is precious. We know that. But if you have your low frequency cleaning aspects with larger bubbles, over time your instruments can take a beating. Let me continue to explain this a little further with you. First, about differing powers. So lower power density, if you have less power, well, you're going to be able to produce less work. So it could take longer to clean. But if you have really intense power, higher power density produces stronger cavitation, and over time can also compromise the life of the performance of your instruments, as seen in the depicted on the right side, where pitting can form. Let me demonstrate this a little further. There's cavitation in industry. Okay, so you can have an instance where you have machines that clean with so much power, like in the case of this mechanical part, where the paint is literally wiped completely clean. This is a side-by-side before and after comparison, split screen put together for your visual purposes here. And that takes quite a bit of power to clean like that. That's obviously would be a tremendous detriment to your surgical instruments. So in the case of this is really a very good example of damaging cavitation. This is an impeller, like in a well pump or even a propeller, say on a boat, because it's underwater, it's experiencing these negative pressures and it's causing cavitation in water. And this damage can actually ruin propeller blades and impeller blades. Also, an appreciation of cavitation in nature. And it is a force that's used in nature. In this particular example, there is the mantis shrimp. And what it does is it has this appendage, like a praying mantis, and it attacks its prey by beating up on a shell and creating a cavitation bubble like you see here, where actually a high temperature can emanate, but the real effect is happening because the cavitation bubble is creating that implosive effect that allows it to catch its prey. So you really understand a little bit better now about cavitation and perhaps gained a better appreciation of that, that power that you use every day and perhaps take for granted. But ultrasonic cleaning is only as good as the time and effort you take to make it right, to do it well. Let's talk about point of care cleaning just a little bit. Now, it used to be point of use cleaning, and AAMI has now adopted the point of care terminology. I'm not sure if it's been fully published yet, but it's been adopted. Okay. Let's first start with this graphic that Gettinga has provided us. And I like to call this the continuum of care. So let's think about it. We've got your ultrasonic cleaning process, but that's only one part of the big cog. If any part of your chain, your process breaks down, the whole system breaks down. So point of care cleaning, all the documentation states that pre-cleaning is to be performed at the point of care. That makes sense, right? We've all been fighting over this, and we also have been fighting about trying to work together. But it's obvious that it's clear that is the fact. Point of use or point of care pre-cleaning. So the Da Vinci robotics, it's a very big deal with pre-cleaning, keeping your instruments moist, right? Can you look at all of this on a distal end of a SSI instrument? All of the areas that can trap all this really nasty bioburden stuff, and all the ability to try to brush all this is quite difficult. And you have to take your device and actually articulate the arm in different positions to be able to get in there and clean it. I think you can have a better appreciation of this as we remove the distal cap and get inside the actual SSI instrument. This is the blue instrument, right? If you look in the upper left corner of your screen, you have two flush ports, port 1 and port 2. Port 1 at the upper part, actually the bottom, and there is a tube from this connection goes down the shaft. And if you look in the middle of the slide there, you see the flush port 1, where the fluid enters in, the cleaning fluid is flushing, and then it reverses back out into the housing, where down in the bottom right-hand screen, you can see where the other port would flush and cause all the bioburden that's been backed up in from the shaft into the housing and flushed out there. So, and another way of looking at it, there's a sort of an aerial view of an XI instrument showing the two flush ports. And in the diagram in the middle that shows the blue, where the fluid is actually pushed down, cleaning fluid, right? We're trying to flush this out, is traversed down the shaft, reverses everything back into the shaft itself, and then awaiting for flushing from into the shaft itself. So again, a little more thorough breakdown on the appreciation of the complexity of these instruments. It starts in the OR. And then you further pre-clean in the decontam area. So this applies for all the robotic IFUs, and Intuitive Surgical has done a great job in producing, excuse me, universal IFUs. And you've got the multiple steps there. And of course, then ultrasonic cleaning is clearly indicated. And when you're connecting your robotics to adapters for flushing, make sure that they are firmly seated. as you would expect, but do pay note of that. You can apply a little resistance on that to make sure that they're fully connecting. Another thing that I would like to tell you is that I believe that the robotics have now got a UDI, the unique device identification coding on their systems that helps matching counts much easier with the reprocessing that's required. So I know it's always been kind of troubling to try to keep up with the counts, and you know, how some people mark them with dots and other things to try to keep up their cleaning with this. Let's look at an indices document a little bit for the robotic instruments, which are available to you. There is in the top there, POTS scissors. It says number of uses 10, number of reprocessing cycles 15. So what does that mean? Well, you could have your instrument in the OR and it won't necessarily be docked. So, but it does count as a use, but it hasn't been used. And so it still is in the OR and it comes down and does need to be reprocessed. You can reprocess it 15 times and you can use it 10 times. But in the case of the black diamond micro forceps, its number of uses is 15, but you can reprocess it 20 times. So there's a difference of 5 times, let's say, that it could be in the OR open and not actually docked with the robot or used. But also I want to point out to you that the differing numbers, the number of uses, 10, 15, 10 to 8 millimeter DeBakey forceps, all your robotic instruments don't always have the same number of uses available to them. So I do recommend you looking into the indices that's available wherever you can find your IFUs, which I'll mention a little bit more about that in a moment. So always pay attention to your AAMI guidelines. I know that sounds like it's common sense, but if you really think about it, let's drill into AAMI a little bit better and some of the more recent things that have been suggested and delineated, clarified in them. But the folks that go to these meetings, that for from all sorts of industry and education and facilities, all work together, lower their barriers, and working to create these documents for making things safe for you to, you know, processes to follow. It's really phenomenal. Some of the more recent things, and these have been out for a little bit, but still want to point these out to you. Like reusable brushes should always be cleaned after each use and should be disinfected or sterilized at least once a day. Cleaning and disinfection, general considerations. This is pretty straightforward, but removal of soil contaminants by cleaning and to inactivate microorganisms by disinfection and sterilization. So this process involves the following sequential steps: point of care processing, number 1, and of course, thorough cleaning all the way through the disinfection and sterilization process. But on the topic of ultrasonic cleaning, you want to make sure to only use or clean those instruments indicated by the IFU. To change your cleaning solution, use fresh solution after each use. This is particularly important for ophthalmic machines because you don't want to have you know, detergent and other constituents remaining in the basin and manage to stay on an instrument and get reused. TAS is not a pretty thing, and I know you know that. But consider that, and we also suggest that you even have your own, you know, dedicated machine for ophthalmic purposes. Gross soil to be removed and thorough rinsing at the end. Again, you know, task can occur because you haven't rinsed the instruments thoroughly because of any sort of residual detergent that may have been found. So, you know, thorough rinsing at the end. You know, just keep these things aware and ever present in your mind. Degas your solution prior to use. Degassing allows this gas, in effect, that's dissolved in the water to be eliminated, and it actually sort of like makes the water more solid. So actually, the cavitation process can be more effective. All of our machines does that automatically for you. Avoid placing plastics and soft metal like lead hands in the ultrasonic cleaner. for one, they might not do any good, or two, they might, depending on the actual material and how soft it is, might deteriorate, and other contaminants might leach off of your instruments and affect others. Ultrasonic equipment should be cleaned daily. We'll talk a little bit more about that. Remove or don't use rubber or silicone mats. And the rationale is that they absorb or impede sonication. So it's kind of frowned on if you want to use smaller trays to capture smaller instruments and things of that sort. That's recommended. It's not recommended to use rubber materials. So for ultrasonic loading, place the items in open weave or perforated metal baskets below the water level and put your heavier items on the bottom. Okay. Don't sonicate power tools because they can't handle shortages in their motors and have their cables be leached with fluid and cause shorting. That's not a very good thing. Plastic or rubber items, like we mentioned, they can impede sonication, so they actually can absorb the sonication, and therefore adjacent instruments can be affected and not cleaned as thoroughly. Follow the IFUs. Can't say that enough, right? I know you've heard it enough, right? But just need to keep pounding that in, right? Keep like metals separated. There's actually kind of a bonding or a welding that can occur between unlike items. So it's really good so that you don't create this galvanic process or effect in your basin where metals are leaching out and metals are touching each other, causing pitting against each other. So not a good thing. And of course, don't overcrowd your instruments. Try to make sure you have enough throughput for the instruments or the machines that you acquire. Ultrasonic unloading. Carefully remove instruments. Yes. Don't damage your instruments and don't damage yourself, okay? Take it easy. I know it's hard saying, hard following through that because, you guys are so busy. If connected to any flushing ports, disconnect. Again, you're busy. You might want to rip the instruments out there, just out of the machine. Just take your time if you can, or methodically remove them. And the sonic if it doesn't have a rinse, then rinse and inspect for cleanliness. Now, there's a lot to be said about verification. Of course, visual inspection, there's a lot to be said about that. Okay, so with regards to verification and of cleaning your instruments before they are sonicated, take a look at this example here of this residual bioburden that was left on from all the processes, from the steps from OR through, point of care down through pre-cleaning. Your ultrasonic machine does great things, but it still has to be delicate about what it does. So please be sure to make sure visually all of your bioburden is removed off these instruments through the pre-cleaning process. And again, like I said earlier, ophthalmic instruments should be cleaned in a dedicated machine. Keep preventive maintenance up to date. So you take care of your machine, we'll take care of you. Plain and simple. So for verification testing daily, for cleaning effectiveness, verification tests should be performed and to ensure that all items are clean. Daily cleaning, drain the cleaner, wipe and mild with a mild disinfectant and cloth, and rinse and dry thoroughly. Don't use corrosive chemicals. You don't want to damage your machine. Again, following the manufacturer's IFUs, the MIFUs. Okay, so equipment inspection, check for leaks on a daily basis. Look around your machine, look on the floor. Is anything puddling? Is there anything spraying? Is there anything going on where you have any extraneous fluid that's coming out of the machine? And also, very importantly, change your filters. Your machine can't clean unless those filters are clean. Okay, so be sure to change those. Minimum weekly, preferably daily, cavitation. Confirm cavitation is occurring in your system. Remember your speakers, that's creating that sound, that powerful effect. And if they're not happening, they're not cleaning. Okay, so we'll talk a little bit more about that in a moment. And minimum weekly for lumens, confirm that the ultrasonic can clean lumen instruments. And again, visually inspect. Now, a very easy to use verification is for cleaning is thing called wash checks. But for verification, mechanical cleaning equipment performance should be tested each day it is used, and all results should be recorded. And in this case here, with the item you see, wash checks, they're very good for easy record keeping and for trend analysis, and they're very inexpensive. There are several verification products out there. I'm showing you this one because you have these metallized coupons with a blue soil on them. And through the sonication process, ultimately, you will have, if you can alleviate the metallized coupon, the aluminum strip from its soil, you will have a pass. That's the goal. And you can take these and easily affix them into a book, a record book, and like you see here in this example. So they are great for record keeping, and they provide evidence for accreditation audits. Really key. You know, they come in, they want to check your processes, and you can open that book right up. Knowing your machines are working properly can have an impact on lowering infection. Now, with regards to bonded transducers, there's something to pay note of, and that is when you have a machine with bonded transducers, you'll have your array of the transducers that are bonded or mounted on the underside of your basin, and you have these cold spots that can form between them. And this can decrease the efficacy cleaning of your system, particularly if you have a bonded transducer that's failing and you don't even know it. So we need to do an inspection on that, or a check, to know that if we have a failing transducer, we need some service. So here's a foil test that's been tried and true. You've heard it probably many times, and it is great for easy record keeping, very inexpensive. This is showing the pitting that occurs when you have these foil strips inside your basin, and the sonication is effective. And also, of course, again, check water flow through your lumens, check your lumens. Let's talk a little bit about resources can help round out your knowledge and education and make more than just your sonication working for you. And that is, make sure to reach out to a lot of your associations, ask them questions, reach out to them and ask them about certain standards. They're there to help you. OneSource, a great resource, 165,000 links to IFUs from over 1,400 manufacturers. Now there's a bevy of information. Well, how can you cut through that? Well, for the example of cavitation, here's an example of an IFU from these ophthalmic instrument companies. And you have the need to find out something about your cavitation process, your ultrasonic cleaning. So I'm not suggesting, not reading your IFU, but if you really want to cut to the chase, you can type in Control F for find on a PC, or Command F on a Mac. And in the upper corner, you see we've typed in ultrasonic, and then it takes us right to the relevant information we need. Okay, so OneSource is a great place, and you can quickly get the information you need at hand. Then there's also groups that you can follow. I recommend that you join AAMI, become a member. Then you get to join the AAMI members discussion group and find out all the things that's going on, all the chatter in the background, problems and problem solving. It's a wonderful resource. Podcasts. Many of you have heard of Hank Botch and Justin Pullen's podcast has been going on for years. And they just have so much information with people coming on, giving all sorts of valuable ways to work with instrumentation and knowledge. It's a bevy of fantastic information. We have our own newsletter called Newsflash at ultracleansystems.com/newsflash. It's free. It's once a week. It's late breaking medical news, and very valuable. We've got job leads. We've got information on ISHM state chapters, upcoming events, some special quotes, all kinds of special articles. We have a feature writer that writes an article for us every week, and we have about a dozen writers writing for us. It's all free and for you. Now let's think about it for a second. This is an old episode of Lucille Ball. You probably have seen this before. The episode, that is. And Lucy and Ethel are trying to wrap bonbons on a conveyor that's ever progressively getting faster and faster and faster. And it's just become such a frustrating environment that I'm sure you guys can relate to this. Lucy says, I think we're fighting a losing game. And let me help you by giving you a few key takeaways for ultrasonic systems and your purchases and thoughts for this. So, ultrasonic cleaning is a powerful and highly effective tool indicated for the vast majority of surgical instruments. If it's used correctly, okay, IFUs and other guidelines and resources help to prevent infection. And from point of care to pre-cleaning in the OR through SPD reprocessing, collaborate with each other and help reduce infection. And of course, reach out to resources, talk amongst your friends. I really appreciate your time, but let's get to something that you also, I promised you, also we talked about earlier in the beginning, some things we're going to offer to you. And we're going to give you email. I'll give you my email a little bit. So if you have questions, if you have already submitted questions, that's great. We'll get to those. But also, I'll give you my personal email and you can reach out to me directly. So we have a book that in conjunction with our newsletter, Newsflash and UltraClean, have produced with 18 articles by Hank Balch. And it's called Think Outside the Tray and Make the Most of Your Sterile Processing Career. This is the front line, volume 1, 18 articles, 4.5 credits. We're going to give away one of these books. I'll show you the link in just a minute. Okay. And then also, rickschultz.org has a set of 163 flashcards, beautiful flashcards. He's already had a couple of books out, The World of Surgical Instruments, beautiful photography. So we've got the stack of cards here, and we have, again, like flash type format, sort of blank on the front, and it's loaded with all kinds of information on the back. So we're going to give away one of these sets. These just came out, so you'll be one of the first ones to get these, likely. Also, we're going to give away to a bunch of these thumb drives here that fit nicely in your wallet or billfold, and they handle several gigs of information for photos and that sort of thing. Also very special. Out of all of these entries we're going to do from all these sessions, we're going to grab one person and we're going to pay their way, give them a scholarship to Isham in 2021 at Columbus, Ohio. Okay, so that link is showing on your screen now, and that's www.ultracleansystems.com/connect. Okay, ultracleansystems.com/connect. Go there, fill out the form, and we're going to give away one of these items each, and then of course put everybody in the hat for giving away that scholarship to Isham next year. So my email is tom.overbey@ultracleansystems.com. Again, the website for just the main sites, ultracleansystems.com. Please, if you have any questions or have already submitted them, we'll get to those. I'll respond to you after this. But I want to thank you very much for everything you do to keep patient safety high. And in just a moment, the code for this CE course will be presented to you on screen. I thank you again, and I look forward to talking to you and seeing you in person. Thank you.